reflection and the factory pattern. We've spoken a fair bit about reflection while describing the factory pattern as well as the abstract factory pattern. They've come to be very closely associated, so it's worth our while to spend some time understanding what is reflection and how it can be used. Now, one of the very basic things that you'd want to do in Java is to create an object of a class. And this is called instantiation, when we want to create an object of a class. The usual way we'd instantiate a class would be with a line of code which looks like this. So say we want to instantiate an array list, and for now let's leave generics out of it. Let's just consider an old-fashioned array list. We'd say sum list is equal to new array list. We'd use the new keyword and specify exactly the class that we want to instantiate and assign it to a member variable of that class type. This is normally how we'd instantiate a class. However, it's also possible to instantiate an object from the name of a class. So we don't know the actual class, we just know its name, and it's possible to instantiate an object from the name of the class using code which looks something like this. If you notice, this class also instantiates an array list called onTheFlyList, but it's very different. We have a class.forName, which is a static method on the class, which takes in a fully qualified name for a class and then calls new instance. This line is basically a way to decide on the fly what kind of object that you want to create. Why is it on the fly? You notice that string java.util.arraylist. This could just be a variable which holds that string, and you could change the value of that variable to be another string. Say you don't want an array list, you want a hash map instead, or you want some other class which you've defined. All of that can be passed into the forName method. So you decide on the fly what kind of object you seek to create. Now, these techniques used to create and do stuff with classes and objects at runtime or on the fly is called reflection. If you pause and think about it, reflection allows you to dynamically instantiate a class not when you write source code, that is at compile time. Instead, you can assign a class name to a variable and instantiate it on the fly. There are two terms which are used together fairly often. They are related but slightly different, and it's important that we understand what they are and what the differences between them are. Reflection and type introspection. These two terms tend to be used pretty much interchangeably, but they actually refer to slightly different concepts. Let's try and understand what exactly they are. What is reflection? Reflection is the ability at runtime to actually create objects of classes, invoke methods on those objects, and manipulate the metadata of objects. So this is important. Let's kind of let it sink in. Reflection allows you to create objects of classes which are specified at runtime. Once we've created these instances, reflection allows us to invoke any methods on it or manipulate metadata. Type introspection, on the other hand, is the ability at runtime to explore the type of an object. Say we have an instance of a class available to us at runtime and we don't know what exactly that class is. Type introspection allows us to examine that class and figure out what member variables it has, what methods it makes available to us, so on and so forth. So what are the questions or what are the abilities that reflection provide us? We can create an object of class foo. We can invoke methods on it. We can access private members. And this is true even when we use reflection from a third-party jar. So we can see the private variables of classes which haven't been created by us. What does type introspection help us with? It can answer questions like, what class is this object? Does it satisfy a certain interface? What are its member functions? What annotations are available on its member functions? So on and so forth. These are the questions which type introspection helps answer. Reflection is more about creating an object and invoking methods on it, and type introspection, you already have an object available and you want to know more about it. Now, the whole bunch of capabilities that reflection and type introspection offered us, as you saw on the previous screen, would make you wonder what are the drawbacks. And it turns out reflection does have some significant drawbacks. Here are some of these on the screen before you. Complexity. Reflection is very complex and using it is not trivial. Performance overhead. Code using reflection can be significantly slower than code without reflection. Security considerations. The whole idea that you can examine the member variables of a particular class which does not belong to you, that's pretty scary. Violation of abstractions. The ability to kind of introspect an object, see what its interface is, see its member variables, all of these put together violate the encapsulation of an object. And reflection allows you to do that. Let's look at each of these in turn. Complexity. Now, reflection is by no means easy to use. Even very simple operations can become unexpectedly complex when we use reflection. Let's take an example, and that's the very simple example of just instantiating an object. Instead of just newing it up, you have to write code which looks something like this. Now, we instantiated an array list here. And look at all the code that we wrote to make this possible. The whole for name, new instance, and then whatever object you got, you had to cast it as an array list. Not only that, I'm not sure if you noticed that we instantiated an array list of the old world variety and not an array list angular braces string of the templated generics new world variety. We know that using generics is better in every way. However, we still instantiated an array list. That's because instantiating generics using reflection is surprisingly convoluted. And we didn't really want to get into that. And that would obscure the point of the example. So generics, which are supposed to be easy to use and which you should use if you can, because it gives you a lot of type safety which the old world classes did not, we can't use that easily using reflection. Also, notice how we specified the name of the array list class. It had to be fully qualified. We have to specify which namespace array list lives in. And if we hadn't, we would have got a class not found exception. So look at all the details we have to consider before we can use reflection. And this is just the beginning of the complexity. The second point, performance overhead. Why is reflection less performant than regular code? Let's just think of what reflection does. By definition, reflection operates purely at runtime. It is at runtime that it figures out what classes to instantiate, how to do it, so on and so forth. Now, the entire concept of Java and the Java virtual machine, like all compilers, does a whole bunch of optimizations to improve code performance. It checks, whether methods can be inlined, whether unnecessary lines can be removed away. All of these optimizations are by definition at compile time. So this whole bunch of compile time optimizations, which are done by the Java virtual machines, is not available for reflection. So anything that uses reflection is a lot slower than if done the usual way. The whole idea of casting an object, these little bits of incremental code add to performance overhead. Basically, reflection should not be used for performance critical code. Generally, code in the user path where the user waits for results after being processed, if that code contains reflection, it will perceptibly slow down the time by which the user can get his results, leading to a degradation of your system. Let's consider the security considerations. Now, reflection is entirely runtime based and it allows you to do a whole bunch of powerful things which you wouldn't be allowed to normally. This runtime on the fly nature of reflection is what makes it flexible and powerful. However, what does this mean? The implications of this are that it's impossible to know in advance what the code is attempting to do. In fact, that's also a reason that code cannot be optimized. It's very unclear at compile time what your code using reflection is trying to do exactly. Now, this can be a security hazard. And for this reason, if you use reflection, you need elevated runtime permissions for this code to run. So anytime you use reflection within the code, the environment that which you're running in requires elevated permissions. Now, if you think about runtime environments in your development cycle, that's totally fine. You probably are admin on your machine and you can run your code using elevated permissions. But in production environments, this can be a problem. You do not want production environments to have complete permissions because you have a whole bunch of other code which could take advantage of the loopholes in your production systems. For instance, applets, Java code which run on browsers, have very tight runtime security restrictions and do not allow reflection. And this can be true for any production environment that you want your code to run in. The very first thing you would have learned about object-oriented programming is that it provides abstractions which completely decouples you from the implementation details of an object. Abstraction is a key underlying principle of object-oriented software design, and it is a key reason why it's powerful, why you can build huge complex pieces of code and still have it be maintainable. For example, if you just think about interface-driven programming, it's all about abstraction. An interface specifies what the underlying implementations can do. And the implementation of that interface worries about how it can implement those methods. It doesn't need to worry about what methods it needs to implement, that it has already been given by the interface. You don't really need to know how an interface is implemented when you're using it. You just know what methods the interface exposes, and that is all that you need to integrate with. Now, if you think about reflection, it gives you unfettered access to the implementation details. You can figure out what the values of all the private variables are. You can look at all the private methods which hides away the private details of a particular object. This can kill abstractions and lead to poor code design. If your design relies heavily on using interfaces, it means that you're not keeping your objects properly encapsulated and away from each other. There is nothing wrong with using reflection, but it has to be thought through and you have to use it carefully in order to avoid these pitfalls. So we've seen, we have all these issues with reflection. When you use it carefully.